Hello everybody and welcome back to Math 7. Today is lesson 6-9. For those of you who are a little bit confused, because on Canvas it skips 6-8, don't worry about that. I went through it and I think it's something that we can afford to skip right now. So we're just kind of moving ahead and yeah. So today we're going to be looking at slope-intercept form of an equation. So we have dealt with a couple different types of linear equations. We had y equals mx, which of course is a proportional relationship, a multiplicative one, and y equals x plus b, which is of course an additive relationship or non-proportional. So today we're going to be talking about kind of throwing those two things together to give the general form of any linear line that we see on a graph. So there is a way to write an equation so that we can easily see the slope and y-intercept without doing any math or calculations. So this is going to be super easy. You don't have to worry about calculations or anything. We can just look at a graph, look at an equation, and be able to either visualize the graph from an equation or find the equation if we're given a graph. So it'll be super easy here. So if we haven't really dealt with y-intercept yet, but all the y-intercept means is where our graph hits the y-axis. So right there would be a quick example of a y-intercept. And this happens when x is equal to 0. You'll get y equals something when x equals 0, and that is your y-intercept. All right. So the slope-intercept form of an equation is putting the two that we know together. So instead of y equals mx, or just y equals x plus b, now we're going to have y equals mx plus b, where m is our slope and b is our y-intercept, where that thing hits the y-axis. So the equations we've been studying is y equals mx, so this is our slope here was m, and our y-intercept was, well, that's kind of technically a plus 0 there, but we don't write it, and that's why it goes through the origin. Our y-intercept is 0 there. And then for y equals x plus b, our slope is kind of hidden right there, but for those ones our slope was always 1, and then our y-intercept was anything except 0. So if we had y equals x plus 4, well then our y-intercept would be 4. And since there's nothing in front of the x, there's an invisible 1 there. 1 is our slope. So if we take a look at our first equation here, our slope for this guy is going to be, well, what's in front of the x being multiplied? Well, that is 4. So our slope here is 4, which means that there is a rise of 4 and a run of 1, because 4 over 1 is just 4. And our y-intercept here, there's nothing after it that we're adding, so if we wanted to add it there, we could have a plus 0, and that'd be easy to see that our y-intercept is 0. Alright, so for our next equation here, y equals x plus 8, well, what is our slope? So we don't want to say that there's nothing in front of our x, so our slope is 0, or else the x would disappear. If we had 0x, there would be no x there. So there's really a 1 hiding in front of that x, so our slope is 1. And our y-intercept is 8. So really easy to just look at these equations and tell what our slope and our y-intercept are. So I want you to pause for the rest of these before I go through them, and then give it an attempt on your own and see if what you get for your slope and your y-intercept matches up with me. So go ahead and pause, give this one a try, and then hit play and you will see what happens. So I'm just going to move on here. So our slope in this case is, well, what's next to our x? What's our m number? Well, in this case it is -3. And our y-intercept, we don't have anything out in front of there. We have no b, so our y-intercept is 0. All right, next one. So remember, pause, give it a try, and then come back. So out in front of that x, remember, is an invisible 1. Pretty simple there. So our slope is 1 for this guy. And our y-intercept is, since it's minus 3, well, our y-intercept will be negative 3. Y equals x. A lot of people get confused when they see this one, dealing with tables and whatnot, but just think of it in that y equals mx plus b format. So out in front of that x is once again an invisible 1. And do we have a b going on there? Well, we're not adding or taking away anything, so our b, our y-intercept, is actually 0. All right, so remember, pause, try it, push play. So here, out in front of our x, our m number, our slope is 1/2. So that just means we're rising 1 and running 2. So this will be a shallower line than the rest of them. And our y-intercept, well, out there after we are adding 5, so our y-intercept is 5. And then y equals negative 2/3 x minus 3. So remember, pause, give it a try, tell me the slope and y-intercept, and then check to see how you did. So our slope here, our m out in front of that x, is negative 2/3. Don't forget the negatives with it. It's really important there for slope and y-intercept. And then our y-intercept here, well, it's plus negative 3 or minus 3. So our y-intercept is negative 3. So really easy to look at a linear equation and see the slope and the y-intercept. And that kind of helps us visualize the line here. All right, so now we want to try to graph an equation without doing any math. So first we want to start by identifying the slope and the y-intercept. We can abbreviate that by saying that. So in our equation here, our slope is 1 and our y-intercept is negative 3. So we've identified those from our equation. Now we want to put a point on our graph at the y-intercept. So we said our y-intercept was negative 3. So remember, our y-axis goes up and down. So we're hitting our y-axis at negative 3. So we have put a point at the y-intercept. Now we want to start at our y-intercept. It's really important that we start from there and use slope to count up. Sorry, let me find here. 1 second. So we count up our rise and our run, I believe. Yep, rise and run to plot another point. So if we start at our y-intercept here, our slope was 1, so that means our rise is 1 and our run is 1. So I'm going to go 1 up and 1 over, and there's another point on this graph. 1 up and 1 over, and there's another point. So we're going to plot a few of these. And then finally we're going to use a ruler, or if you don't have one, that's okay. Just draw the best straight line that you can. And we want to connect our points and put arrows at the end of our line. And there we have it. We just graphed a linear equation just by looking for the slope and the y-intercept. So be sure that you're counting up your rise and doing that first. So rise is up and run is to the right. Or if you have a negative number, rise could be down too. So we could have negative rise for a negative slope. All right, so it's really that simple. So just start by finding your slope and y-intercept for the equation. Then we want to plot the y-intercept first, and then plot new points by using our rise and run. So another quick example, if I had y equals negative 1/2 x plus 2, well, my y-intercept is 2, so I would plot the 2. And now we have negative 1 over 2. So that means I would drop 1 for that negative 1 and then go over 2. Drop 1 and go over 2. So just another quick example here of a line that we could have. And then we put our arrows on there, and it's really that simple. So don't be confused by any negative slopes or anything. They work the same way. We just got to go in a negative direction instead of the positive direction. All right, so as like most of the time, our independent practice begins here. So no need to draw this graph here. You can just count it from your computer here, but I do want you telling me the slope and the y-intercept of each of these lines. And then our assignment will continue on the next PDF in our Canvas page. So try your best. Remember, if you have any troubles or questions, feel free to email me or send me a message on Canvas, and I will get back to you as soon as I can. All right, thank you, and we'll see you again tomorrow. Bye-bye.